tips and tricks for managing this interview. How will you know that you will have become a pro or you're ready to face the interview questions? So I've divided the learning of high-level system design into 4 categories. This is the holy grail of system design. This is the most important part. A lot of times your interviewers are going to try to confuse you. Let's talk about a few frequently asked questions. What is the impact of AI on HLD? Another extremely important topic. Right before the interview, make sure that if you're someone who's interested in high-level system design, maybe for interviews or maybe you're just exploring and learning it in general, then this video is for you. In this video, we will not just talk about the topics that you should be studying. Of course, we'll cover that. But for each of these topics, we'll also talk about the learning approach, about the depth in which you could be learning these topics, about the tips, tricks, strategies while learning. And especially for interviews, I'll be talking about these tips, tricks, and strategies in a lot more detail, because high-level system design is a very broad topic, and covering this level of design in a 45 minutes or a 1-hour interview is a different ballgame altogether. So I'll help you with tips and tricks for managing this interview. I will tell you how you could be driving your interview and how to handle different kinds of questions that are going to be thrown at you. So we have a lot to cover. But before we move ahead, let me just tell you there's not going to be any promotion. I just want to tell you that why I am the right person to be telling you all of this. For those of you who do not know me, I am Keerti Purswani, founder of EduCourses, and over the past few years, I have taught tens of thousands high-level system design. And at EduCourses in the past 2 years itself, hundreds of people have got their dream jobs because of my teaching. So I know the kind of problems that people usually get stuck in. So even if you're not getting any paid course, how you could be approaching and learning for free, that is what we are going to be covering in this video. The only request is, please do subscribe. Your one free subscribe and share would motivate me just so much. I genuinely believe that this channel deserves 1 million subscribers, and if you feel so too, please do share and subscribe. It would mean the world to me. Let's get started. Let's begin by a basic but important question. What is high-level system design, and how will you know that you are at what level of learning high-level system design? How will you know that you will have become a pro or you're ready to face the interview questions? See, the goal over here is that if I pick any system around me, if I pick any application, and I'll give you examples of these systems and applications, but the goal is that if I pick any system, I should have an idea of 2 things. I should have a good understanding of how this system is working internally. And second thing is that I should understand why it would have been decided that the system should work like this. I know it sounds vague, but we'll talk about this in detail. First, let's talk about the different systems or applications that you could think about. Think about any application that you're using. Think about video streaming. What do you use? Netflix, Prime, YouTube, and so on. For chat applications, you use WhatsApp, Discord, Slack, right? What is the difference between these systems and how they must be working internally? What would be the difference between how they're working internally? Like WhatsApp, Discord, Slack sound similar, but what is the difference? Similarly, other systems like Uber, Ola, or maybe Swiggy, Zomato, or e-commerce platforms like Amazon, Myntra, or you could take different systems like Airbnb, Shopify, Spotify. So pick any system, any application. We should understand what are the different components internally. So when I talk about internals, what will be there? Firstly, there will be a lot of components, right? So I should understand what are the different components. Then I should also understand how these components are interacting internally. Not just internally, but also interacting with our outside world, right? Not just within the system, but outside the system as well. So we should understand what are the components. We should understand how the interactions are happening. We should understand all the data, right? How we are storing the data. Why are we storing the data like this? How is the data being sent, right? So all of this, we should have a clear understanding of how the system is working internally and why it was decided that the system should work like this internally. So I've divided the learning of high-level system design into 4 categories. This is what I also used and cracked multiple companies, and this is what I used to design the curriculum of our EduCourses high-level system design course also. This is what thousands of students have enrolled for. This is proven. Many students have cracked their dream companies. So the point is that you can follow this. This is a very standard way as well. So I'll talk about these 4 categories on a high level first, just to give you a broad idea, and then we'll talk about the topics in each of these categories in detail. See, when I was telling you about the goal of high-level system design, I told you that we should understand how the communication is happening between the different components of the system, right? This is where networking comes into picture. We should know what are the different modes of networking, different ways of networking, not just between the components of the system, but even with the outside world, right? So that is why the first category is networking. You should understand everything about networking in detail. The second category focuses completely on data. Data is very important in any system, and we should have a clear understanding of the options that are there to store the data, what are the different databases that are available, and why would we choose to store a particular kind of data in a particular database. So the second category is about databases and data stores. The third category focuses on the concepts that are specific to high-level system design. So you must have thought that all of these systems that I have been talking about are used by billions of people. So these are very scalable systems, right? So how do you make sure that these systems don't crash when billions of people are using them? So we talk about scalability and a lot more concepts in detail about high-level system design, that how will you make sure that these systems can be used without breaking down, and what are the different components that are going to be there in your system for that. So the third category focuses completely on this. In my Recourses course, I had 2 weeks focusing on just these concepts. And in the fourth category, we finally bring the concepts of these three categories together to build end-to-end systems. So we get our knowledge of how the networking is going to happen, how the data is being stored, what are the different components, how can we make sure that our system is going to be scalable, and all of this together. So we are now ready to talk about the end-to-end system design. So the fourth category focuses on taking a lot of examples of different systems and understanding that, okay, this is how it is working end-to-end. Before we talk about the topics of each of these categories in detail, let me tell you the most important thing that you need to know in high-level system design. This is the holy grail of system design. This is the most important part of the entire video. This is very, 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 very important. Please listen to this very carefully, right? So any system that you can think of, take any example, any system, there is never going to be one right answer that you can just go and tell in your interview. Even for, like, pick any system, say suppose Netflix system design, if you went through one particular design online, you can't just go and vomit it out in the interview. It might not work. Because in an interview, the expectation is not just that were you able to tell, I'm going to use this database, I'm going to use this networking protocol. That is not the expectation. The expectation is, were you able to tell why that particular database you are choosing? Why are you choosing to use this particular networking protocol? Were you able to tell the pros and cons of the databases, the networking protocols, the design decisions? Were you able to tell the trade-offs? So the entire system design discussion that happens is about trade-offs. At every step, you have to understand the pros and cons. You're going to tell that this is the decision that I am making. These are the implications of these decisions. So you need to understand what will be the implications, what will be the pros of your decisions, what will be the cons of your decisions. In fact, a very, very important interview tip over here. A lot of times your interviewers are going to try to confuse you, right? So it is an art to be able to handle it properly. Suppose you say that I'm going to use database A and your interviewer tells you that use database B instead. So you cannot be firstly adamant that no, I'm always going to use A only, but you can't always go like, okay, because my interviewer is saying, so obviously interviewer is right, so I'm going to agree to database B. No, it doesn't work like that. You have to give enough reasoning for A versus B. So suppose you suggested A and your interviewer suggested B. You have to be able to tell pros and cons of both. You have to be flexible over there. You have to say that I chose A because so and so reason, but B might work for so and so reason. This was my thought process. If we decide to use B, then these will be the pros, these will be the cons. This is my thought process in the decision making. And that is what your interviewer is looking forward to. The thought process, the reasoning behind every decision that you're making in your system design. Let's talk about a few frequently asked questions. A very, very common question that I have been asked since AI has become so famous, since AI is trending, it is the thing everyone is talking about, is what is the impact of AI on HLD? Now that AI is trending, should we know any more extra topics for high-level system design rounds? See, for ML engineers, there is a separate machine learning system design round. And if you are interested to know about that, in this video, I have covered recommendation system, machine learning system design. But that is different. Currently, we are talking about software development high-level system design round, which is pretty different. If you talk about high-level system design in software dev perspective, there is not much change because AI is currently being used at a lower level only. You can think about it like AI is being used to, say, generate some kind of code, to generate some logic. But when it comes to overall design of scalable big systems that are used by billions of people, there is not much change. There is one small change that you can think of, that is that a lot of systems have now started using one new type of database, which is vector databases. You might have heard that to be able to store embeddings or vectors of words to understand the semantic meaning of the words, vector databases are used. And if you're interested in that, I have this video where I've covered the concept of embeddings and vector databases in very simple way, so you can check that out. But other than this, there is no major change. In short, you can continue learning HLD the same way. There is no impact of AI on HLD as such. Another question that I hear a lot is that, am I going to be asked to write code in high-level system design round? See, in high-level system design, we talk about the different components, how the interaction is going to happen, so networking, we talk about the data storage, so databases, data stores, and so on, and some high-level system design concepts to make sure the system is scalable, can be used by billions of people. Now, it is true that internally, each component is in the end code. Everywhere internally, there is code only, right? And yes, as software developers, you and I should understand how to write code in the most efficient way possible. And yes, there is designing for that. But that comes under low-level design. Let me repeat that. There is high-level system design, there is low-level system design. High-level system design is where we talk about the components, the networking, databases, making our system scalable, can be used by a lot of people. Low-level design is about how do we structure the code, how do we write a code that it is very, very efficient so that it can be used by a lot of people, so that we have to make minimum changes in the code, everyone can understand it, and so on. That is a completely different topic, low-level design. High-level system design is completely different. I get this question a lot at edu courses also. This is one of the most frequently asked questions, that do we take LLD course before HLD or should we take HLD before LLD? You can do both parallelly. You can choose whether you want to do LLD or whether you want to do HLD first. That is a personal decision. But let me tell you how it works in terms of interviews. In interviews, usually first there are DSA rounds, then there are LLD rounds, then there are HLD rounds. Now the number of rounds and everything depends obviously from company to company. Let me talk about high-level system design. See, usually high-level system design is asked when you have 1+ years of experience, but it really depends on the company. Some companies have started asking high-level system design from freshers also. Yes, I have heard that from freshers also high-level system design is expected, maybe not into that much level. Freshers might not be able to answer so many questions like maybe about different databases, networking, and so on, but they are asked, right? So some level of expectation is there from in some companies for high-level system design. So my point is that it really depends on the company. Some companies ask the fresher level, some companies start asking when you have 1+ years of experience. Companies like Google start really late. It is very surprising that Google asks a high-level system design when you have like 7-8 years of experience. So it really depends on the team and everything. But usually the interview rounds are that first DSA is asked, then LLD is asked, then HLD is asked. As your years of experience is going to increase, the usage of HLD is really going to increase, the importance of HLD is really going to increase. Just think about it. See, when you join as SDE1, SDE2, you are obviously expected to write code, right? So to be able to write code more efficiently, you should know LLD. Then when you have an upper level understanding, higher level understanding of architecture, then you become really good at HLD, right? So what is happening when you join as freshers, you might not know anything, but then you start learning to write code most efficiently, so you learn LLD. Then you start understanding the overall architecture, so you become really good at HLD. Here I would like to emphasize on a very, very important point. This is quite important. Please listen to this carefully. HLD, especially for interviews, according to me, is a one-time effort. Once you understand the basics of networking, databases, high-level system design concepts, then right before the interviews, you won't have to spend so much time. Now, I've seen this in thousands of students. I've seen that once they have completed the course, after that, right before the interview, they just need to go through the cheat sheet to make sure that they don't miss anything in the interview, to make sure that they're able to drive the interview, that they cover all the points, that they talk about all the things that they should be talking about. So cheat sheet, maybe basics of API design, capacity estimation, basic revision is required. That usually takes like half a day, 1 day, max 2 days, and that is enough. Okay, and let me explain this a bit more from my experience also. When I was interviewing for multiple companies and I cracked these multiple companies, I had a time crunch and I had given myself like this many number of days. So I was giving like HLD, LLD, DSA rounds on the same days. So I was spending more time on practicing DSA because everyone needs practice for DSA, right? So for LLD, HLD, I did not need so much of revision because HLD, once you understand the basics, then before the interviews, you can just go through it and you can just revise the concepts because it is endless, right? So once you have understood the concepts, you have understood it, now you will be able to participate in the discussion. In fact, here is a very, very important tip that I give to a lot of software engineers. Please listen to this. This will be really helpful in your career. As software engineers, once you've understood the high-level system design concepts, start noticing the systems around you. When you use Zoom, think about how is the communication over here different from, say, watching a YouTube video, and how is the networking over there different from, say, watching a live cricket match, right? Start thinking about these systems and start asking yourself questions. So start reading about it. So once you're not sure, just open your phone, just chat GPT or Google or understand. There are enough and more blogs about it, right? So once you have spent some time on the basics of high-level system design, notice all the systems around you. It will give you so much confidence as a software engineer that you understand how systems work. And not just the systems around you. A lot of people make this mistake in the team that you're working on. No? A lot of people, they will just go, they will just do the work that is assigned to them and they will come back. But as software engineer, do you really understand the system that you're working on? Do you understand the architecture of it? Now, architecture really depends on the team that you're working on, how big the product is. But usually what happens is that you have to understand the architecture of your sister teams also, the teams that you're working with, to understand the overall architecture. So do you have that understanding or not? A lot of people will understand it, okay, I'm working on this component. Now I have no idea how this component works with the rest of the components of my system. You should have that understanding. In fact, a lot of companies have a dedicated interview round where some technical lead is going to come and ask you the design of your previous company. So you should be able to explain this really well. And I have had these rounds in multiple companies where I was asked to explain the system design of my previous product, of the product that I had been working on in detail. And there is so much cross questioning. This is to see whether you really understand the systems that you're working on. So it is really helpful in terms of interviews also, and it is really helpful for you for growth also. See, when you start understanding the system that you're working on, you will start contributing to your team in a completely different way. You will start contributing to the discussions. You will ask the right questions to your manager, to your technical lead. You will ask that why are we taking this design decision? Why is the networking happening like this? Or why are we using this particular database? So that discussion will also show your technical lead or your manager that you're really interested in the system and you really want to grow. That is the path of a software engineer, that you start coding, but slowly you start learning about the systems around you and the systems that you're working on a broad level. That is what architects do, and that is what you're expected to do as you grow. Basically, the point over here is that even though from interview perspective, HLD is honestly a one-time effort. Once you know the basics, once you have gone through the common examples of system design that are available for interviews, then it is done. Then you just need quick revision and you just need to be able to communicate the trade-offs really well in the interview. It is one-time effort, like you will be ready. But other than that, HLD as software engineers is ever growing and it is never ending, right? Like in databases itself, for interviews, it is just enough to understand that, okay, these are the common databases, these are the pros and cons, and you need to be able to talk about the trade-offs. But in reality, as software engineers, it is really interesting to understand how these databases are working internally, the common decision making that different companies are doing for these databases. So your understanding for each of these databases will become really deep, right? Like this networking, like understanding on a higher level just for the interviews is really enough. TCP versus UTP, WebSockets, polling, enough. But other than that, if you read a lot about it, you will start understanding why different companies are making different decisions. That is everlasting, ever growing thing. Like you can go through so many tech blogs, you can keep watching a lot of videos, you can start going through so much of code online, right? So as software engineers, keep doing that. But from interview perspective, it is honestly one-time effort. Like it is not really hard to crack interviews. It is just that you should know how to drive your interview well. You should know the right questions to ask. You should know the cheat sheet. Let's finally discuss the topics in each of the categories one by one. The first one is networking. This is very important, as we have been talking about in the entire video. First thing that you should definitely cover is TCP versus UTP in a lot of detail. So many shots I have covered on my channel also in detail. TCP versus UTP is a very, very common question that is asked. Then the next one is that you should understand client to server protocol in detail. You should understand HTTP, HTTPS in detail internally how it works. For HTTPS in my course, I have also covered symmetric versus asymmetric encryption, how the encryption is happening for HTTPS internally, so that the understanding should be completely clear. There can be so many follow-up questions in your system design discussion just related to these topics. Another very common question that comes, especially in messaging systems, it is very common in all the systems, will be for server to client communication. So client to server communication is very easy, right? Client server protocol. But server to client communication, there are a lot of questions that come around this. There are 4 solutions, and these are very, very important. You should definitely know about it. Short polling, long polling, web sockets, and server sent events. Very, very, very important. You should definitely know. For long polling, short polling, I would suggest that you should be able to write some basic code snippet to be able to understand what is the difference between them. We have done that. This will really enhance your understanding. Okay, so these concepts should be completely clear. Other than this, you should understand RPC. So gRPC you should be aware of, WebRTC, RTMP, and so on protocols. A follow-up for networking would be understanding message queues, synchronous and asynchronous message queues. Even if you have not worked with Kafka, you should have a basic understanding of Kafka and RabbitMQ for sure. Coming to data stores, a lot of people think that for HLD, SQL versus NoSQL databases is enough. But that is far from true. There is so much that is there into data stores and databases. In fact, at EduCourse's HLD course, we have dedicated one entire week just for this topic. So let's just talk about the topics one by one. SQL, NoSQL databases, you should definitely start from there. You should definitely know it in detail, pros, cons, trade-offs. Definitely read about it a lot. But after that, please understand that we are talking about our systems at scale. We are talking about our systems being used by billions of people. So our databases should also be capable of scaling, right? So we should be able to talk about vertical scaling, horizontal scaling. Then we are going to have so much data. So we are going to divide it into multiple shards. So we should know different kinds of sharding that is there. The follow-up topic, which is extremely important, discussed in almost all the systems, is consistent hashing. Very, very, very important topic, consistent hashing. Then we need to know the different types of caching. Caching, very, very important. We need to be able to retrieve the data as fast as possible, because data is stored in multiple databases in different locations. So that should not make our system slow, right? So how can we retrieve the data as fast as possible? The different types of caching, we should know about it. Other than this, please understand that our data is going to be present in different locations on cloud, right? So whenever, especially consistency is very important, it is very challenging. So we should know about asset properties. We should know about distributed transactions. So distributed transactions itself is a very, very detailed topic that you should know about. And once you know all of this, at least, you should spend some time understanding all the databases, at least the famous ones, the different kinds of databases that are there, at least once. Like what we have done at EduCourses is that we have picked different kinds of NoSQL DBs, okay, and we have done demo and like detailed discussion of one of each of these kinds of databases. Let me explain. So like SQL, you can pick any one, right? Like you can pick anything, like you can use MariaDB and you can see a demo of that. You can try using it yourself. Other than that, we have done MongoDB, we have done Cassandra. For time series database, we have covered InfluxDB. For graph-based database, we have covered Neo4j. We have also covered one blob storage, so you should also do that, like AWS and all, you should know about it. So different kinds of data stores, just know the famous ones, the pros and cons of it, the trade-offs. So you should know that why a particular database is being used. And once you have like the entire clarity, once you're capable enough of talking about pros and cons, then slowly you can start reading different tech blogs and you will understand why a particular company chose to use a particular kind of database for a particular use case, right? That is how you will become really good at discussing about database and data stores. Also, when you're going through these databases, it will be really helpful. Like if you're either doing demo or you're trying a very simple project yourself, then it will be helpful to see the querying as well. Like especially for SQL databases, sometimes the interviewer might ask you to write a simple SQL query, or for example, if you are dealing with say Cypher query language or any other simple queries, right, like for MongoDB and all. So it will be really helpful if you have some experience of working with different kinds of databases and you are able to write some basic queries, CRUD operations. That would be like an extra point. You should definitely be able to do that with more experience. Coming to topics that are specific to high-level system design, the first thing that you should definitely know about are the different components that can be there in your system. So the first topic that you should definitely know about is monolith versus microservices. A lot of people assume that at scale we always deal with microservices, so there's going to be no questioning around it, but they can be. So your understanding of monolith versus microservices should be clear. You should be able to answer questions like when would you migrate from monolith to microservices, maybe different kinds of migration techniques. This is something that we covered in the course and it was pretty interesting. Not necessary, but I would definitely recommend going through different migration techniques from monolith to microservices. It's really interesting. Other than that, with microservices, what are the different components that are very commonly used? Load balancers, you should definitely know about them. Different kinds of load balancing techniques, different kinds of load balancers that are out there. API gateway versus load balancers. You should know about proxies, forward proxies, reverse proxies. Read about something called service routing, so you are able to stitch everything. Another extremely important topic in high-level system design is CAP theorem. I know I've been saying this for a lot of topics, but guys, I don't think I've seen any system design round discussion without the CAP theorem discussion. So this is that important. CAP stands for consistency, availability, partition tolerance. So you should know about these three terms in detail. You should understand what is consistency, what is availability, what is partition tolerance. You should also understand few more terms like latency, throughput, so that you are able to discuss this, right? After CAP theorem, the immediate discussion is consistency versus availability. Also, one more tip over here, guys, whenever you're studying any topic, okay, say databases you're studying, so pick examples in your head. Like for example, if you're learning about say MongoDB, think about in Amazon, what kind of data would I store in MongoDB? What would be the pros and cons of that? Say Netflix, where would I use Cassandra over here? The pros and cons of storing this kind of data using this kind of database, right? Similarly, when you're learning about CAP theorem, think about it. In this system, where would I prioritize consistency? Where would I prioritize availability? Similarly, when you are learning about short pulling, long pulling, think about the use cases. Where would I use long pulling? Where would I use WebRTC? Where would I use RTMP? So the examples in your head are already there. So while learning the basics, you are sort of making yourself ready for the end-to-end system. Capacity estimation is a topic where literally you will have to do some maths calculations either on laptop or on pen and paper, but you would have to do these calculations, and usually there are two calculations that are usually expected. One is the data storage, so you would have to see that this is the data that I am storing and roughly it is taking this much space, so I would need this much of data storage space in say 5 years or 1 year or 10 years and so on. So you're doing some kind of estimation, right? The second kind of calculation that is expected is the bandwidth that you would require. So in this request, how much data will be coming or will be outgoing, right? So that kind of calculations is expected. So as I had told earlier also, usually right before the interview, this is what people revise because they don't want to spend too much time on calculations at the last minute. So right before the interview, make sure that you are able to do calculations really fast. So just do some quick practice. Basically, you should be able to do conversions really fast, like maybe from MB, GB, TB. These conversions should be really fast. Your table of twos and these conversions, like how many zeros in millions, billion, trillions. So just do some quick revision. Like in my course, I had given some rough cheat sheet that, this is how you can do the calculations quickly. So you know that this is the calculation that has to be done. This is usually required. So make sure that you do not spend too much time in your interview because you have limited time in the interview, right? You have 45 minutes to 1 hour. And in that, you should be able to do quick calculations. You don't want to waste your time in maths, right? You just need to be able to do it as fast as you can and move ahead. API design is another topic where you will have to write down your design decisions in detail properly. Like while designing, you will have to talk about the request, the response, the headers, the body, the status code, the method that you're using. You should have a very clear and thorough understanding of get, put, post. There can be a lot of questions around put versus post, right? So these discussions you need to be able to handle really well. So APIs, you need to be really good at it, but just not this, okay? A lot of people miss this. Suppose you're designing a get request for say your e-commerce platform and you're getting a products. So while designing your API, like which is a get request, you are supposed to talk about pagination and filtering. A lot of people miss this. See, high-level system design is not just about knowing these topics. You might understand pagination and filtering, but if you do not talk about it while designing a GET request, then it is your fault. Your interviewer is not supposed to say, oh, you missed pagination, you missed filtering. You need to remember. That is why cheat sheet will really help, and I'll tell you how to stitch all of this together. But make sure that you are driving your interview. Make sure if you are designing a GET request, you talk about pagination filtering. Also, rate limiting is very, very important when it comes to API design. So keep these things in mind that, okay, I need to talk about this, I need to talk about this. I'll also talk about the cheat sheet now. Before we move on to the fourth category and stitch everything together, I would just like to mention a few topics that are not given enough importance, but there can be some interviewers who are very specific about this. So make sure that you don't lose your cool and you have read about them at least a bit. So logging and monitoring, you should know at least a bit about it, right? So the different solutions that are usually used. You should know about failure and fault tolerance, very important. You should know a bit about security. So make sure you read about it if you have time. This can be asked in an interview, and there can be some interviewers who emphasize on this. Once all your basics are clear, stitching everything together is pretty easy and you should be able to easily do it. There are a lot of designs that are available online, so you can see a lot of solutions that are already available. On my channel also, I've covered a lot of videos where we have covered end-to-end system designs. I've done a lot of mock interviews with different people, so that will also give you a lot of idea about how interviews usually go. Because see, system design, as we have seen, is a very broad topic. So you need to be able to drive your interview well. You need to be able to allocate time for particular discussion. Because see, if you end up discussing about databases only for half an hour, then when will you discuss the rest? It's a red flag, right? You can't just be discussing about, say, networking protocols for half an hour. When will you talk about the rest? Your interviewer's expectation is going to be that you drive the discussion, you make sure you're allocating time for everything and you're able to discuss about everything in detail. So once you go through a lot of designs, you will see a pattern over there. You will see that usually first functional requirements are asked, then non-functional requirements are asked, then capacity estimation is done, microservices are discussed, API discussion happens, API design happens, then database discussion happens in a detail, then other small things like logging, monitoring and all of this. If anything is left, maybe a bit of some algorithm if that has to be discussed, but this is the usual flow that is there. Okay, I have a video dedicated to what are the questions that you should be asking in a high-level system design interview and how you should be driving your interview well. So that video was like a few years ago, I think during COVID. So even though the quality of the content is really good and it is like I still stand by it entirely, the sound might not be so well. So if you would want me to create another video dedicated to that, another one, a newer version, just let me know. I would love to do that. And this is it. Just spend some time focusing on end-to-end designs. The more designs you go through, the more you will understand it, how you will be able to drive your discussion in your interview. Before ending the video, I would just like to say that even though I mentioned all the topics, it might seem like there is so much to study. Honestly, HLD is not really so hard. If you know basics of coding, if you have worked in any company, if you have even basic experience, then HLD is actually very interesting and it gives you just so much confidence because you understand how all the systems around you are working. So it is a very, very satisfying experience to invest your time in learning HLD, and just once will give you so much confidence. And about the time, so let me tell you that I have, like in my course, I have taught it in 5 weeks. So even beginners are able to learn it properly in depth in 5 weeks, and that too they are spending 3 days a week, right? So it is just literally, I think, 30 plus hours and they are able to do, right? So if you actually sit dedicatedly to watch the course, you can actually finish in 2 to 3 days. It is humanly possible, right? So it is not absolutely impossible that you cannot do it fast. It is possible to learn it really fast, and it is possible to learn it in depth also. Just make sure that you cover all the topics and then spend time going into details, because it is an ever growing process. Like it will always happen, you will always learn so much more, but just make sure that you cover everything once to get the confidence and then keep reading more about it. This brings me to the end of the video. I hope you enjoyed it and you found it helpful. Thank you for watching till here, and if you watched till here, I'm guessing you really like the content, right? So please do subscribe and consider sharing it with your friends. It would mean so much to me. And if you have any other suggestions for any other videos, like if you would like me to create a low-level system design roadmap or any other thing like this, any other topic that you would like me to cover, I'm covering a lot of tutorials, AI-related stuff also right now. So if you have any suggestions for topics or any topics that you're scared of and you would like me to cover, let me know. I would love to do that. And please subscribe, share with your friends. It would mean so much. See you next time, guys. Bye.